Good evening, boys and girls. Today I am going to talk to you about momentum, the concept of momentum. So this is our lesson 4, and so get out your paper and pencil and let's take some notes, okay? So one thing that you will learn from this concept of momentum that you'll understand is why do big trucks or why does the bigger vehicle, cause so much damage in an accident? Why does the bigger person knock the littler person over, even though the little person is working really hard? So why does Bryce, my 5-year-old, knock my daughter down when they're both moving at the exact same pace? They just bump into each other by accident, right? But how come? How come that happens? And the answer to all of these questions is momentum. Okay, so here's the situation, okay, in which we have a truck and a car, okay? They have different weights, or different masses, I guess I should say. Let's say that this truck is moving 75 kilometers per hour. We're going to stick to those kilometer measurements. So this one is moving 75 kilometers per hour, okay? And this one right here, this car, okay, much less mass, okay, so it has much less material in it, much less matter in it, is moving at 100 kilometers per hour, okay? If they collide, so if they do in fact collide, which one will be more damaged? Which one is going to be more damaged? And most of you guys, from just the picture and from experience, would know that this car, okay, would be more damaged, the little truck, if they were in there. And the reason for that is because of this concept of momentum. Okay, so this is what we're studying. Sorry, this is what we're studying today. Okay, so let's talk a little bit about what that means. In general, all moving objects have momentum. One thing that you need to know is that the more momentum an object has, the harder it will be to stop for that one object, okay? So the more momentum an object has, the harder it will be for that object to stop. Secondly, I want you to know that momentum depends on the mass of the moving object and the velocity that it is moving. And so, as it turns out, okay, and so as it turns out, we have an equation for this, okay? So now that you have that in your notes, we have a nice little equation for this. And the equation is, oops, go back, sorry. The equation is right here. We can find the momentum of any object by looking at its mass times its velocity will be equal to the momentum. So in here, what's interesting is P actually means momentum. Let me change colors here. P actually means momentum. And so that's just the symbol that we use. Also, the way that this is written is a little tricky, but it looks the most inviting. But we use the big M to represent mass. We do not use the little m. And then velocity is a little v, and this is what is velocity. So the units for mass can be anything from grams to kilograms. Velocity is going to be something like miles per hour, kilometers per second if you're using SI units, or meters per second will be seen, okay? And then again, P is equal to momentum, okay? So let's go ahead and try to do a calculation that has this in it. Sorry, all that clicking, I know it's not very fun to hear. Okay, so let's try an example. Suppose that this truck right down here is traveling in this direction, okay, in this direction, and let's say that it is traveling at 75 miles per hour, or sorry, 75 kilometers per hour. So this is our same kind of example that I did at the beginning of the slideshow. And let's say that this truck has a mass of 1,000 kilograms. So if we want to know its momentum, we say, okay, again, it is m times the velocity. Okay, sorry, that should be lower. And so what we would do is, the math we would do is we would say 1,000 kilograms times the velocity is 75 kilometers per hour. And so our answer would be, sorry, I kind of put that out of order, but then our answer would be 7, 5, and 3 zeros. What happens to our units? Really nothing does. You keep the kilograms, you keep the kilometers, and it's still per hour. Okay, so the momentum of this truck right here is 75,000 kilograms times kilometer per hour. This car over here is moving in this direction. Okay, so it's moving in this direction. It is moving, though, a bit faster. It's moving 100 kilometers per hour. And it has a mass of only 500 kilograms. So it's half the mass, but it's moving much faster, right? It's moving faster, but it has half the mass. So let's see what its momentum would be. So to line it up a little bit better, momentum is equal to mass times velocity. So the momentum is going to be 500 kilograms times 100 kilometers per hour. When you do the math, multiply 500 times 100, we get 50,000. 1, 2, 3 kilograms per kilometer per hour. And so when you compare these two, even though this car is moving much faster, the momentum that each of these have is different. And the momentum for this truck is much more than the momentum for this car. It's about 25,000 kilograms per kilometer. I mean, kilograms by kilometer per hour. Sorry. So that's why. So that's why the truck can honestly do a bit more damage. Okay. So even though the car is traveling faster, the truck has a greater momentum. Okay. What about the question of which one will take longer to stop? So which one of these, if they're moving at the same kind of pace, at the same speed, if they have the same mass, let's say that this one is a mass of, I don't know, we could say again 500 kilograms. This one is also 500 kilograms. Sorry, this color is fairly obnoxious, but let's say that this one is moving the 100 kilometers per hour. This one is moving at just 50 kilometers per hour. You know, as you know already, if you're going slower, it's faster to stop, right? If you're on a bike, if you're on a skateboard, whatever it is, if you're snowboarding or skiing or sledding, you know, the faster you go, the longer it will take to stop for you. And that's for me why I get really nervous when I'm going down a hill very quickly, because you know I know it's going to take longer to stop. I'm going to have to anticipate a little bit better. So which one is going to have the more momentum? Now we know the 500 times 100 will be a larger number than 50 times 500. Okay, so that's why it will take longer, and the reason is because it simply just has more momentum. Okay, an object with, so in your notes you should have an object with a large momentum is difficult to stop. Okay. So it's going to be harder to stop. So go ahead and search another example of this, which I think is hysterical, and I look at quite often, is if you search on YouTube adults versus kids on slip and slides, you will definitely see the slip and slide has very little friction, so everything's going to just move, right? It's moving because of that water, and they put soap on it, and so it's pretty funny. I have a link here that watched this video of just a woman going down and then a man flying down. But I don't want this video to be too long, so you can go ahead and search that, and I think you would find some very funny examples. So with that said, let's talk about what happens. So further, to take momentum a bit further, what happens when a moving ball hits a ball that's stationary? Okay, so if you look at this, you hit the cue ball, I think is what it's called. It bumps into all of these. It bumps into all of these balls that are stationary. They move, right? We know that they are going to move that stationary ball. And the reason is because the momentum of a moving object is transferred. So maybe I should write this down. Momentum is transferred from one object to another. It's transferred between objects. Okay. And then there's even another rule that says that it's called a law, actually. There is the law of conservation of momentum, meaning that momentum is conserved. Whatever momentum was in an initial object will be in another object if it bumps into it. So it says total momentum of any group of objects remains the same unless outside forces act on the objects. Okay, outside forces, hopefully you're thinking right away, friction. Okay, friction is often what it will slow down anything that is in motion, as you know. Okay, so let's look at some examples of collisions and see how this conservation of momentum will work. So let's say that we have cart A, and it's going to bump into, so it's moving towards this. And let's say that this is going at a pace of 4 meters per second. Okay. Let's also say that this is 100 kilograms. And let's say that cart B is also 100 kilograms, but as you can see, its velocity is equal to 0. So cart A is at a velocity of 4 meters per second, and cart B is at a velocity of 0. It's not moving at all, it's stationary. If we calculate the total momentum within this, we would say that the momentum of this cart A is P is equal to 100 kilograms times 4 meters per second, which will give us 400 kilograms per meter times second. This has no momentum at all, so we would say plus 0. So the total over here in the beginning, the total momentum is equal to 400 kilograms per meter times second. Remember, I'm not forgetting to put in my units. Okay, catch me if I do. Let's say that it does crash right into B, into cart B that had no momentum at all. It wasn't moving at all. Assuming that there are no outside forces, okay, there are no outside forces, meaning it's not sticky, meaning there's no friction, there's nothing happening here. Cart A will transfer all of its momentum to cart B, and so now cart B is going to be moving at 4 meters per second, okay? And cart A will have no velocity whatsoever, okay? And so between the before scenario and the after scenario, according to our conservation of momentum, we know that there will still be a total P of 400 kilograms per meter times second. And so all of that momentum was transferred over to cart B. Okay, that's in a non-sticky collision where the cars don't link together, they don't touch after the collision occurs, which can often be not the case, right? When collisions occur, there's sometimes And so here's an example of a sticky collision, okay? This sticky collision, let's say that we are starting with kind of the same scenario. They are both 100, both carts are 100 kilograms, 100 kilograms. This cart is not moving, so zero momentum, zero velocity, sorry, no momentum coming from this. They are going to bump into each other, so cart A is going to bump into this, but we know that the initial momentum is equal to 400 kilograms per meter times second, okay? There's none here, so P of cart B is 0, but P of cart A is 400, okay? What is the velocity? So the question is, what is in a sticky collision, what will the new velocity be if the carts stick together? Okay, and you've seen this. If a ball hits another ball, usually they both continue to move a little bit, right? They both continue to move a bit until they both slow down. So we know that now we have a new object. It's no longer two separate carts that have a mass of 100 kilograms. We now know that our new mass in this situation is 200 kilograms. Okay. We know that our P value, our momentum, is 400 because that's how much was in the initial scenario before they bumped. So we know that there is a conservation of momentum, meaning that there's not going to be a change of momentum at all. The question is, what's the change in velocity? Because we've now changed the mass, okay? So now we just come to a nice, straightforward algebra equation where we know this one and we have to solve for V. So if P is equal to 400 kilograms times m per s is equal to the new mass of 200 kilograms times the velocity when we divide both sides, and here I'll change colors. Oops, sorry. Okay, if I divide both sides by 200 kilograms, 200 kilograms, I'll totally cancel out the 200 and the 200, and I'll be left with a V. And then I'll cancel out the kilogram unit. This will be 2, 400 divided by that. So the answer will be 2 meters per second will be equal to the velocity. So that means that our new velocity is 2 meters per second. So it slowed down because the mass increased. So that's a sticky collision number 1. Now, I was just at the playground just a couple minutes ago, actually, and I saw this kind of sticky collision, and I thought it would be totally relevant. So here are two young men, right? Two young men. This is the before. So he's on the slide, and he stops because he sees that I'm videoing. This one perhaps doesn't see that I am videoing, so he just goes ahead and continues down the slide, okay? So let's say that this little guy weighs about 40 pounds. We're going to go to pounds, sorry. And let's say that this little guy weighs 70 pounds. And I happen to know these kids, so I know that that's pretty much the case. Let's say that initially this kid was moving down. What did I say that he was moving down? Let's say he was moving down at a rate of 6 meters per second. And let's say that this guy, as soon as he starts, he is moving at, 12 meters per second. So he's moving twice as fast as this one right here, okay? So initially, these two objects combined, what is their total momentum? So we would come over here and we would look at initial momentums, okay? Initial momentums, meaning that we would do P is equal to 70 times 12 for the bigger kid. And so that would be 840 pounds times meter per second. And so this is the green shirt guy. And then this cute little guy, well, the green shirt guy is very cute as well. But the maroon shirt is, his value is P would be equal to 40 pounds times 6 meters per second, and we would get there, we would get 240 pounds times meter per second. Okay, so the total between these two is we add the 840 to the 240, and we get a grand total of 1,080 pounds times meter per second. Okay, so this is the total momentum in both of these objects. So then what happens is, because they happen to be friends, this kid, when he's moving down, they're cousins actually, when they're moving down, he's not going to push him, right? Well, in a sense, he's going to push him. He's going to just grab right onto him, okay? And so then they're going to move on together. And so the question is, what is their new momentum, okay? So the after momentum, after they bumped into each other, after the collision, okay, their mass has now changed because now they're a combined unit. So now the mass is going to be equal to the 70 pounds plus the 40 pounds, which gives us 110 pounds. Okay, and we know what the total p-value had been, so let's use a little bit of algebra. We will figure out what the velocity is by knowing that 180 pounds times meter per second will be equal to their new total mass times their velocity. Okay, so when we solve for this, we will get that the velocity is equal to 9.8 meters per second. Okay, so this little guy speeds up because he was initially going 6 meters per second. This little guy was going 12 meters per second, so he will slow down. He will experience a slowdown. But together, they will continue to move down the slide. Okay? So again, in a force-free situation, this is what would happen. Now, if you think about it, how many ways do we know how to slow ourselves down on a slide? So how do we know how to create friction to slow us down and bring us to a stop on a slide specifically, right? I know about 100 ways to stop myself on a slide, including jumping off a slide. So watch what happens and tell me if you think that this was accurate. Okay, did they start speeding up, or what happened to their speeds as they moved? And hopefully it works. Okay, so that's what happens. So I will see you pretty soon when we start talking about our next topic. Have a great night.